Let's start with the third major AHU type. So this is the third type which I am discussing right now. And the third type is the dual duct constant air volume. So I hope you understand this is DD and CAV. And this is how it would be noted in most of the research paper or textbook. So you should understand that dual duct constant air volume means DDCAV, or DDCAV means dual duct constant air volume. And let's start with the schematic for this. So we'll have an outside air coming, a return air coming from there from the zones, and some would be exhausted outside, exhaust air. Now this would be going through a this will be going through a preheat coil. So this mixed air, outside air and return air, gets mixed up and it is called as mixed air, which goes through a preheat coil. After the preheat coil, what we have is two separate, we'll have a fan which is called as supply fan, because we can have a separate return fan also, that's why. From the supply fan, what we have is there are two separate ducts, and that's the reason it is called as dual duct. Earlier what we had is, we had single duct which is supplying air to my zones. Over here we have two separate ducts. The first will be handling the cooling coil. The second will be having a heating coil. And the heating coil and the cooling coil have a set point temperatures which are already fixed, which are TCC and THC. Heating coil leaving temperature and the cooling coil leaving temperature. We'll have a terminal box or a mixture box which will combine the cool air and hot air and supply to the zone. And from the zone we'll have that air coming back to exhaust or return. And in the same way it could be supplied to other zone also. So this could be the first zone, this could be the second zone, and in that way we have n zones available to us, where my heating coil and cooling coil will have combined supply of air, hot air and cool air. The beauty of this is, in the earlier setup what we had was a cooling coil, and then at the end before the zone we'll have a heating coil. What does that mean is, we had the same air which is cooled first and the same air we are heating again. That is a loss of heat, loss of energy, because we are just heating and cooling, that's a loss. Over here what we are doing is we are separating those. The cool air is not heated, the hot air is not cooled. But still there is some energy loss, because in the mixing box what we are doing is we are mixing cool and hot air together. So over there is some loss, but in the zones when we want to supply some, we want to maintain a temperature of, let's say, 75 degree Fahrenheit. And the supply temperature based on the sensible load which is given to us and the latent load which is given. Let's say the supply temperature is 68 degree Fahrenheit. And my cooling coil leaving temperature is set as 55 degree Fahrenheit. The heating coil temperature, let's say it is set at 100 degree Fahrenheit. So if I want to maintain a 68 degree Fahrenheit, what I'll have to do is, I'll mix some cool air and hot air in a ratio. So maybe I'll take some more cool air, some less amount of hot air, mix them such that the output result of the air which is coming, so we can have a temperature of this air which is 55, this air which is 100, and then which they are mixed. So maybe I'll use 1/3 amount of cool air 2/3 amount of hot air. When they are mixed, the total temperature of this mixed air becomes 68 and that is supplied. And in the same way, the terminal box has to decide the amount of cool air and hot air which is used. So that's how we make the calculations, and the amount of hot air and cool air are calculated using this formula. So this is the ith zone, and the hot air is given by the total volume of the air which is to be supplied to that zone into T IS minus TCL upon THL minus TCL. These are L's, or this could be supply temp. So cooling coil leaving temperature and heating coil leaving temperature THL. TIS is this temperature, and VI is the supply volume to that zone. So that volume is still constant, but the amount of hot air and cool air are to be decided using this formula. And obviously the VIC will be VI total minus VIH. Right, so that's how we can calculate the amount of hot air and cold air which is to be supplied to our zones. I hope you have understood, and that's the overall picture of how a dual duct constant air volume AHU looks like. We have not done all the calculations yet, but this is the overall picture of it. Doing all the calculations will take some more time, and we'll do each of the calculations for temperature, the loads on my cooling and heating coil, and the fan, and the sensible part of it, the moisture level, everything will be calculated in upcoming videos. Thank you.